Entanglement being probably one of the most mind-bending or puzzling
Hence,
phenomenon of quantum computing.
hence the name
And
of our podcast.
exactly, right? There's a reason why the name of our podcast is Entangled Things. So it turns out that two or more quantum particles can become entangled. And by that, we mean they form like a single system where the state of each particle cannot be described independently from the state of other particles. And what's the really kind of mind-bending thing is that if you separate those particles with incredible distances, like even think about light years here. We cannot yet do that for obvious reasons, but even if you separate them with the distances in the order of light years, the effects of measurement will apply to entangled particles. So let's give a simpler example. If you have two entangled particles, you separate them say, on two different continents. One is over here in my house in Europe. The other one is over there, Patrick, in your house in the United States. So what happens is if you measure the particle that it's at your house in the United States, as we said, the state will collapse and you will get a 0 or a 1. But what's unbelievable is that the moment you measure your particle and its state collapses, my particle state will also collapse and I will get a 0 or a 1. By the way, that this phenomenon is one of the things that puzzled Einstein for a long time. He had a really hard time grasping the fact that this is actually how entangled particles work.